Okay, so we've looked at some situations where we've had some graphs and we want to find out, we want to now talk about the practical domain and practical range. And of course, the practical domain is a set of all the input values. And again, practical domain, the D comes before the R, so the domain is talking about inputs. And the range, or the practical range, and the only reason why we call them practical is because they're pertaining to a specific problem. So this video really is to talk a little bit about this example problem. So we have a bathtub with 50 gallons of water and it begins to drain at a constant rate. Okay, so the first thing we want to do is define our variables. And so we know that the bathtub is draining at a constant rate, so that means it's over some sort of time. And so we know that we're going to use T for the number of seconds since the tub began draining. So again, this is our defined variable. And then G is the number of gallons of water in the tub. We could call this a big ordered pair, if you will, because we're putting the input and the output defined variables into an ordered pair. And when we write them as an ordered pair, we know which one is the input and which one is the output, because in an ordered pair, we know that it's always the input, comma, the output in that ordered pair. So when we write what we call this big ordered pair, we have the defined variable for the input, comma, defined variable for the output. So now we want to sketch a graph. Oh, the other thing to keep in mind, anytime you're working with a problem, we always want to make sure that we define our variables first. We want to know what we are talking about, so that then the explanation or the justification or the meanings fall right out of what these defined variables represent. So we're again talking about this bathtub with 50 gallons of water. So notice here that our vertical axis is labeled with the number of gallons in the letter G, and our horizontal axis is time in seconds using the letter T. So our defined variables are on our graph. We're beginning at the point 050 because time is 0 seconds. We have 50 gallons of of water. And we're going to go in, and the graph just goes downward. So as time increases, the number of gallons will go down. So we're saying now, and we're justifying, I drew it diagonally because the situation says a constant rate. So I assume the flow won't fluctuate and will decrease the same amount each unit of time. So so here's our sketch of our graph. So we needed to sketch this graph. And that represents this over here. This is our sketched graph. We don't have to be very particular. We can do some tick marks. We can scale this graph if we want to, or we can just kind of hand sketch it in terms of what does it look like. And then we talk about where the graph begins. Again, this ordered pair happens to also be the vertical intercept. And it's the vertical intercept because, again, a vertical intercept has the point 0, comma something. And so we know anytime we have a 0 as my input, and therefore we know that that's a vertical intercept. So the graph begins at 050. There's 50 gallons of water, and then it decreases at a constant rate. Then we want to identify what is our practical domain and our practical range. Now these can fluctuate depending on your own personal experience or your situation in general. So we're saying that the practical domain is from 0 to 60 seconds. Now obviously that could be longer, it could be shorter, it just kind of depends. So we don't know when we stopped draining the water out of the bathtub. We could let it drain for 3 minutes. We could let it drain for 20 seconds. It just depends. One of the things you're going to start seeing is this notation where 0 is less than or equal to the variable which is less than or equal to the max amount. So it goes from least value to greatest value. You can use the arrows right now if you want, but we're going to get into this notation in the next lesson. So keep that in mind. So then our range, so our practical range is going to go from the least amount of gallons all the way up to the most amount of gallons. So we always go from least to greatest. Another way you would see this would be 0 is less than or equal to G, which is less than or equal to 50. And again, I'm writing it right along the axes so that I can help with that association of which goes with what. So 0 is less than or equal to G, which is less than or equal to 50. So that's another way of writing that.